All right, I guess I'm starting this off. Santosh is going to hide on the side over there so he doesn't have to be in the spotlight. Alejandro Cantarero, I'm a field CTO for AI at DataStax. So what that means is I kind of do all things AI across our customer engagements and some stuff across our product as well. Since we're in Southern California, I've been in AI and been in the LA data community for a long time. I ran data at the LA Times and San Diego Union Tribune for a number of years, which is one of the jobs locals always get interested about. I created their first production AI services, their first data science team, first production data warehouse, first BI, modern BI suite, all that fun stuff. And it was all built on AWS. All right, so what are we going to talk about today? So a little bit about DataStax. I'm guessing there's some people in the room that probably, or maybe a lot of people in the room that don't know who we are. And then, what have we been doing with kind of AWS enterprise support? We've been doing a lot of stuff around generative AI and Amazon Bedrock. Like many people who have already been talking, we also have done some work on migrating to Graviton. And then we did some work on kind of resiliency of our platform, and we'll talk a little bit about a customer case study. So who are we? So DataStax has been around for over 10 years, probably most well known as like the Cassandra database company. So that is our origin and roots. We are still the single largest contributor to the open source Cassandra project. We started with kind of support for Cassandra, enterprise kind of self-managed Cassandra installations, still a big part of our business. Then, we were a little bit late to the cloud, but we are in the cloud now. So our cloud journey started about 4 years ago. So we now offer Astra DB, which is a fully managed database service in the cloud built on Apache Cassandra. So all the benefits of that. We're in about Cassandra is in probably about 90% of the Fortune 500. So, kind of well known for kind of large scale real-time data enterprise use cases. A few years after that, we added streaming to the platform, also open sourced and as a managed service. So that's built on Apache Pulsar. That's a fully kind of Kafka compatible streaming library, but a bit cheaper and, a little bit more open source friendly, fully integrated into our platform. And for a long time, we were using that to kind of build and power a lot of real-time data applications and a lot of kind of traditional machine learning applications. About a year ago, like everybody in the database space, we added vector search to our product and did a very hard pivot to generative AI. So, now we're really kind of building out a generative AI platform to try to really meet AI developers where they are in building their first generative AI apps. At the core of that platform is obviously our database, which provides world-class performance on kind of everything you want, throughput, latency, kind of size of data sets you can deal with for generative AI. And then we've got a lot of tooling that's open source for kind of ease of access for generative AI applications, including a recent acquisition of the company Langflow, which some people may know, which has a kind of nifty low-code visual editor for kind of creating generative AI workflows. All right, so because we're doing so much of generative AI, one of the first things we did was get involved with kind of like Amazon Bedrock as that was coming out. So kind of through our TAMs and kind of working with them, we were able to get preview release access to Bedrock early so that we could make sure that Astra DB and Cassandra were kind of fully compatible with everything that was going on with Bedrock. So if you're building a GenAI app, you want to use Bedrock for kind of model serving, text generation. You want to use SageMaker for some of the things that are not in Bedrock, but you're running custom models you want to use for this. We worked kind of closely with the team to kind of make sure that that was all integrated and worked really well. Because of our huge footprint with large enterprises, security and compliance is a huge deal from us. You see, we've got every certification you would want there, not listed, but also like ISO 27001, PCI, HIPAA. So as we kind of look at integrating with Bedrock and SageMaker and other platforms in the AWS ecosystem and tools that our customers want to use, we need to make sure that that security is tightly in place. And so we've, through kind of our account managers, we've always kind of worked very closely with Private Link to kind of make sure that not only do we work with private link properly, but a lot of our customers will come to us with security concerns where they actually maybe need to be educated on private link and like why it's going to be okay for them to use private link. Sometimes they're a little reluctant, and so we've worked really closely with the TAM team to kind of make sure that we can have those conversations with our customers and make them feel good about the security of their platform. So another thing that we did on the AI front is that AWS launched a generative AI competency recently. And so, companies that kind of go through this process can get, this competency certification and kind of, bring that extra credibility into the conversation that, hey, we can be a key part of your generative AI stack, that AWS kind of views us in that way and that we're kind of fully compatible with everything in their ecosystem. So we went through this process. It was, relatively straightforward. So, we need a lot of guidance, from our TAM on like how to do this, who needs to be involved. This involved quite a large number of teams on our side. Had some involvement. Our partner team had involvement. People from product and engineering. The people that created kind of our vector search index. People about how we play into the broader ecosystem inside of AWS. Like all of it had to kind of come in and be packaged up and presented back to the AWS team doing the evaluation for the competency. So it was a lot of different pieces to kind of pull together, but it was really important for us to kind of get this, and we were really thankful for all the guidance to kind of make sure that we were successful, because the meeting did go well. The evaluators were pretty happy with what we presented, and then obviously we kind of got the competency. On the slide, just kind of give you a sample. This was part of like what we showed them as part of that evaluation process. This is kind of like a standard architecture diagram that we've been using for a while on kind of where we fit in the generative AI landscape. This one's probably a little bit out of date. We have different versions of this now, but why do people come and want a vector database? It's on the left. A lot of it's you're doing retrieval-augmented generation. You're building chatbots. You're building knowledge applications. So that involves RAG, that involves long-term memory for these systems, and also caching for kind of more complex apps and for cost savings. All of that can be done, inside of our platform. And, the architecture above kind of shows what this commonly looks like with our kind of vector database and our kind of streaming services kind of in the middle to kind of move data around, make it available to these applications. And then kind of the LLMs and embeddings that kind of power a lot of these applications kind of come from the Amazon services that we partner with to kind of bring all of that together. All right, so next use cases. We're just going to jump all over the place here because we just do so much different stuff with AWS. So Graviton, like many here, we did do some work with Graviton. A big part of this was kind of our TAM helping us get into the AWS Countdown program. It was Countdown, right? Is that right? Yeah, perfect. I want to make sure I didn't say it wrong. That was like a really big deal for us. I was meeting with some of our product managers last week. If we hadn't gotten into the Countdown program, we would have done this work. So that was kind of like very meaningful to us. As part of, I want to make sure. Yeah, as part of this work, and so we're a cloud-based database. We bill our customers on consumption volumes like kind of everybody else in the space, right? So it's kind of reads, writes, and storage. So for us, kind of optimizing costs isn't even just about, us saving money or being more profitable. Like that gives us the ability to kind of pass those savings on to the customer. We are very proud about kind of our total cost of ownership in terms of our product. It's something that we really are always kind of pushing on to say, hey, like when we're in a competitive, race with some other kind of vector database as a service or general kind of database as a service thing, that we're going to come out on top in terms of cost of operating. So parts of that is that we could do this all efficiently. So, Graviton, big deal for us on that front. Our move to Graviton was, I would say, fairly challenging. We were having kind of a hard time kind of understanding how to kind of optimize our services to run on the platform. In order to kind of figure out what to do, there was actually some metrics that we needed about what was happening on the machines that are not kind of publicly available in the AWS cloud. So we had to work with our TAM to sign an additional agreement to get access to some kind of private metrics that they were then able to share with us that we could then use to actually kind of optimize our installation and get it working correctly. So, a lot of work to go through that. You have to define like what's the compelling reason for this, like why do we really need it, why can we not just use what's kind of publicly available, and a lot of different kind of folks you have to kind of coordinate on that to kind of get access to that type of information. So our account team was able to help us do that, and then we were able to have a pretty successful migration over to Graviton. I was talking with our product team at the end of last week, and it netted about a 20% savings for us in terms of kind of what we were operating in terms of our cloud instances. So also on kind of the engineering side, we really struggled for a long time with EKS upgrades. And the reason is very simple. If you upgrade the EKS cluster, you have to reset the machines that are powering it, which means you have to reset the database. That's like a hard no for us. Like that is like kind of the core value of Cassandra, is that it's like this always on, you're never going to go down, very high scale. There are Cassandra clusters out there that have been running without interruption for like 10 years. A lot of those are not necessarily our customers, but just like open source and others running for very, very long periods of time. So, our customers, we power a lot of mission critical workloads. They don't want that downtime. So it's very complex to kind of schedule with the customer, like when you're going to do the reset. If anything goes wrong with the upgrade, very, very problematic. So basically anytime we need to do an update, it was like getting delayed for months and it was taking a really long time. So we kind of engage with our TAM on that of like, how can we make this better? And basically, the result of that was just them giving us a lot of help on how we could do this properly in kind of test and dev environments, how we can go through a lot of testing and make sure that we're kind of really confident that this is going to go smoothly, and kind of guiding us on how we can do all of that, and then like working closely with our TAM when we go through those testing cycles, so that any issues that come up get resolved like very quickly. And then when we actually do like the production releases, again, just having like our TAM team kind of ready so they know this is happening. So if anything goes wrong, we can address it really quickly. And so it's mostly been just kind of like a process and operational kind of cadence to kind of get this to run really smoothly. But the end result has been really great. I mean, the time that it takes us to put in upgrades now is substantially less than it was before. And, the engineering team and product teams have a lot more confidence when these are happening than they did originally. All right. So as I mentioned, DataStax now a generative AI platform for knowledge applications. So, most of the new business that we see coming in now is all around generative AI and RAG applications. That's probably not surprising to anyone. It's like such a hot kind of subject area right now. So this is an actual architecture diagram from one of our customers that wanted to build a sales kind of Copilot project. Again, really common for us when you think about kind of generative AI use cases that most customers want to tackle right now. The most common is unstructured data querying. I have a set of documents. I want to ask questions about it. Second most common that we see is structured data querying. I have like a database with a bunch of structured data and I want to ask questions about it. There are a few others that we see, but those are the most common, and those are certainly kind of what our customer was doing here, was trying to enable their sales team to much more rapidly be able to find case studies, similar customers in a similar segment, like as their sales reps are kind of preparing for like conversations, like, initial pitches, deeper in the process, try to close a deal, like, we've got this mountain of information, how do we like data mine it really effectively so that we can solve this? So, the top flow is, data is stored somewhere, in this case, under a SharePoint API. You want to extract all that data. They need to get both metadata and the actual text out. Everything is orchestrated through Langchain, which is one of the most popular frameworks for doing this. And so all that orchestration is happening, and then they're kind of generating data with Bedrock at this point to kind of turn all of that into a vector and then kind of store it into kind of our data store. along the bottom is kind of some more advanced like RAG techniques for those that do this. Like you have to do like re-ranking, you have to look at maybe multi-query patterns and all these different things to kind of get your hallucination rates down. So that all sits kind of in a programming layer. And then there's kind of an operational layer, which is kind of the third bucket down, which includes things like LLM tracing, operational metrics with things like Langchain and Langsmith, and then pulling the LLM caching layer. So that would, caching would again come from kind of the DataStax Astra product. And then you can see the actual generation piece. So they happen to be using Claude 2. Claude 2 is one of the many models available for text generation inside of AWS Bedrock. Amazon Bedrock. So, kind of smooth integration into those components, and then kind of finally like the serving of the application on the bottom layer. So basically, like for all of our customers kind of running in AWS environments, there's a lot of different AWS tools that go into kind of building these solutions. This is kind of what my team in the field spends a lot of time on, is helping our customers understand what AWS components they need to kind of build their solution, working with our kind of hack. They need help on like how to properly integrate these products. In this case, it was kind of Titan embeddings and Bedrock for serving. A lot of times we have customers that maybe need to use something like AWS Glue or other services for kind of data movement because they're already using Dynamo or some other kind of database in the AWS ecosystem where their data is stored, but they need to migrate it into kind of Astra in order to power the vector search experience part of the application. So, we always stay very close kind of to AWS to help us understand the latest and greatest that's coming down in their tool set and their services so that we're kind of able to provide the best solutions to our customers. All right, and with that, I'll hand off to Santosh. Finally has to come stand in front of the stage.
Yeah, thank you, Alejandro. So, yeah, this is our call to action slide. So, yeah, hello everyone. I'm Santosh Kumar Jha. I am senior time at AWS, working with DataStax team. So, today we understand the potential of generative AI, and you have seen how DataStax has collaborated with enterprise support and how we have empowered their GenAI initiatives. Hence, I would leave you with 3 call to action, as you see over here, which you can leverage to drive transformative business outcomes. Right? So first, we have strategic support plan, or SSP. This is your roadmap to success. It outlines clear business outcomes aligned with your business vision, and the TAM will work with you to actually define the project milestone as well as the strategies for risk mitigation, right, under the support plan. And then next, we have strategic business review, or SBR. This can be, again, semi-annual or monthly, quarterly cadence, depending upon your needs. SBR measures the progress towards defined outcomes. SBR also provides you a comprehensive assessment of the AWS cloud environment, and it talks about any gaps or blockers that might be there in the project, right? And it provides tailored guidance to optimize performance, security, cost effectiveness, along with topics which cover like risk mitigation and training needs, right? And then third one we have is AWS Countdown. Formerly, it was called Infrastructure Event Management. So this program basically provides a proven playbook and prescriptive guidance when we are doing some large-scale migration or like product launches, even model deployments. So for those cases, we use AWS Countdown. Right? We also have recently introduced a premium tier for AWS Countdown, in which case you will get a dedicated AWS engineer on a monthly subscription fee, who will be the single point of contact for proactive guidance and troubleshooting throughout the projects. So at the end, I would say that, work with your TAM and leverage the combined power of SSP, SBR, and AWS Countdown to achieve your business outcome, knowing that AWS Enterprise Support is your trusted partner, and we are committed to your success. Thank you. And any questions you might have for DataStax or myself, please let us know.
So one question, so are you looking at Claude 3 as part of your Sales Copilot architecture? Second question was, how key the token size in your architecture?
Sorry, the first question, what could you say it again?
Are you looking at Claude 3
Oh, I should hold the microphone. Varies, with customers. But yes, we have a lot of customers looking at Claude 3. The results with it are quite a bit better overall than what you would see with Claude 2. If you were building now, I would not recommend using Claude 2. Having said that, like once people have things in place, like all pieces of technology, right, they're kind of slow to update. I think the second question was on token sizes. A tough thing, there's not great, I would say from my perspective, science around that. Like, a lot of experimentation with kind of what's the right size to kind of chunk and how many tokens to use. A lot of it is dependent upon what kind of models our customers are using. Vast majority are going to use like OpenAI or other third-party services. And those have high token limits. You put 8,000 tokens into those things. Some people that are more concerned about security will be running open source models in something like SageMaker, and those oftentimes have like max token lengths of like 512. So you kind of have to know, a lot of it's driven by model choice, and then after that, it's kind of the nature of your documents. But probably the most common chunk sizes we see are like between 512 and like 1024 for text.
Check online for the questions really quick. No questions online. I think we're good.